Hello everybody. As you remember, last day of class we were working with buoyancy forces. We were doing an example in the blackboard. I'm trying to replicate this example now in this video so you can check it again and practice with this calculation. First, before starting, I want to remember what is going on. So buoyancy is a force that appears when we try to introduce an object in a different fluid. We put this example in the classroom. We have a ball. This ball is like through to the water in like a swimming pool. So if we try to push down the ball, we experience a force against the ball, and this force is the buoyancy. So the buoyancy is a force that the fluid is making against the object, right? And this force is opposite to another force that happened because of the ball having mass. This is the weight of the object. So we have here two different forces. The weight of the object, and this force is due to the gravity. So if you remember, the weight of an object is the same as the mass of this object by the gravity. We are drawing like an arrow over these two letters because it means that the direction of the force is important. And there is another force that is made by the liquid. Imagine that this case is water, so this force is related with the fluid, right? So it's going to be related with the density of the fluid, as we will see later, and it's just opposite to the weight, right? So in this system, as you may notice in this picture, there are two forces. The first force is the weight of the object that is pulling down the object, and there is another force against this weight that is the buoyancy force that is made by the liquid, right? So it's going to be related with the density and the volume of the liquid that has been removed, so by this volume, right? So if you remember, last day in class, we were making a little experiment using a dynamometer. What is a dynamometer? A dynamometer is a device that allows us to measure the weight of an object. We have a rubber similar to this image, and we were measuring the weight, right? In this image, we only have one force, and this force, because the object is outside of the fluid, and this force, as we wrote before, is related to the mass and the gravity, right? So imagine this scale of this force is going to be 10 Newton, right? I don't remember how was the force in our example, but imagine this is 10 Newtons, right? So what force is happening here? So I'm going to try to amplify this object. So this object is something like this, right? And we have only one force because this object is outside of the fluid. So we have only the force due to the weight, right? And this weight is the mass times gravity, and because we are using this dynamometer, is 10 newtons. So the second part of our experiment, we introduce this object inside water. So if you see here, now the force is less. Let's going to compare again with the previous slide. Here, imagine was 10. Imagine this is 10 unit. So the arrow is pointing here in the the next graph. Imagine this is 10. Imagine this is 1. 1, 2, 3, 4, 5, 6, 7. Imagine this is 1. Okay, so why here the force, the weight is lower? So the weight is going to be again the same. It's going to be the mass by the gravity. The mass is going to be the same. The gravity is the same because we are in the earth. So this value is lower because there is another force, a second force, that is pushing up the object. Should be another force that's gonna drive with red that is pushing up the object, and obviously this force is the buoyancy. So there is a second force here, buoyancy, that is pulling up the object. So let's gonna amplify this picture here, so we can draw all the force. We have our object. Again, we have the weight is exactly the same as last time, weight. But now there is another force that happened because we put the object inside the water. And this other force is pushing up the object, and it's the buoyancy. Okay, so, and this buoyancy is going to be proportional in somehow to the density of this fluid, right? And also to the volume of this object, because this volume of this object is going to be the same as the volume of the fluid that is pulling up the object. So, based in our dynamometer, the result of this measure is 1 Newton. So, with these two informations, with these 10 newtons and this 1 Newton, we can calculate easily the buoyancy. It's going to be the difference. If here, in this part of the experiment, there is no buoyancy, there is only one force due to the weight, and in this second part of the experiment, there are two forces, so the difference between these two forces will be the buoyancy. So if we want to write it down, so we can put the first experiment, we get the weight, that is 10 newtons. In the second part of the experiment, we got the weight, so I'm going to write here 1, I'm going to write here 2. Again, it's going to be the same object because we haven't changed it. So the buoyancy is going to be calculated very easily by the difference between the weight 1 minus weight 2. So it's going to be 9 newtons, right? So the force that is pushing up the object in this second experiment is the buoyancy, and its value is 9 newtons. So now imagine that we want to calculate the volume of this object, or in other words, we want to calculate the volume of the water, of the fluid that is making this buoyancy force. Let's gonna see again in the picture. Imagine we want to measure this volume that is the same as the volume of the water that is making this buoyancy. So we can do taking into account this information. Let's gonna delete this information. Just keep in mind that we have that the buoyancy is 9 newtons. So we got that the buoyancy is 9 newtons. So we said before that the buoyancy is a force. So because it's a force, it's the same as mass times gravity, the same as the weight. And also I want you to remember the equation from the density. So I'm gonna write here, the density of the fluid is the same as the mass of the fluid divided the volume, right? So I'm gonna put this equation in terms of mass. So if I want to put this equation in terms of mass, I just need to move this guy here. So the density in terms of mass is the same as mass of the fluid is the same as the volume times density of the fluid, right? So let's gonna write these equations in the other equation. So we can write, you may agree with me that we can write the buoyancy is gonna be the same as the volume density times gravity. Remember that this is the same as mass. Okay, this is the same as mass. Well, if I'm assuming that the first liquid is water, also we know that the density of water in the international system of unit is the same as 1000 kilograms per square meter. Is the same and as 1000 kilograms per square meter. So our goal is to find the value of volume, right? So I'm gonna delete a few things here. To make it clear. So what I'm going to do now is to write this equation in terms of volume, right? And then just I need to replace with the numbers. So if I write down this equation in terms of volume, volume is going to be the same as buoyancy divided density and gravity, right? So let's gonna replace our information. So the volume involved in this force is gonna be the same as 9 newtons divided density 1000 kilograms cubic meter times gravity, and gravity is 9.8 meters divided second square. So let me remove this information. So if we do these calculations, we may get that the volume of my object, that is the same as the volume of the fluid that is making this force, this buoyancy force, is as follows. So making these calculations, the volume is 0,0000918 cubic meters, that you can translate it to milliliter if you feel more comfortable. So we have this volume. So now you may wonder why we need to calculate this volume. Okay, we want to calculate this volume because now we can use the same procedure to establish the density of a known fluid. Imagine we have this another example. We have this other example, and we have here a fluid that we don't know the density. It's not water anymore. So we have again the same situation. We have here the weight. Okay, we have here the weight force. But also again we have the buoyancy force. The buoyancy force that is the opposite. Right? And imagine now our dynamometer, the lecture of our dynamometer is 0.75. So let's gonna write again the force that are involved in this third experiment. So we have the weight, let's gonna write in black. We have the weight of my object, this is the mass times gravity. Remember, we calculated it in the first experiment, it was 10 newtons. And now we have the weight in this unknown fluid. This is the third experiment, and this weight in the unknown fluid is 0.75 newton. So if you remember what we did last time, the buoyancy will be the difference between the first weight and the third weight in this case. So if we write down the numbers, it's going to be the same as 10 minus 0.75. So the buoyancy in this third experiment will be the same as 9.25 newton, right? So how we can calculate, how the density of this third fluid can be calculated? Okay, let's gonna doing exactly the same as the previous experiment. So we have buoyancy, and this buoyancy is 9.25 newtons, and this is the same as mass times gravity. And if you remember, In terms of density, this is the same as density of the fluid that we don't know, the volume, what we know because we calculated it in the previous experiment, and the gravity. So now our target is to establish this value. So we can write down this equation in terms of density. So density of the fluid is going to be the same as buoyancy divided the volume and gravity. So we can calculate the new density by writing here 9.25. The volume was the same as here, 918. So 0,0000918 times gravity, and gravity is 9.8. So the only thing left here is to do these calculations. Let's gonna calculate it. So if you do this calculation, the density of this new fluid is slightly higher than the water and is 1028 kilograms per cubic meter. So this is exactly what we wanted to measure. Okay, so I hope you have understood this explanation. Please don't hesitate to contact me if you have any question.